Now we're going to work through two application problems. So this first one says two airports are 52 miles apart on a north-south line. The south airport sees a plane at a bearing of north 34 degrees west. The north airport sees the same plane at a bearing of south 56 degrees west. How far is the plane from the north airport? Okay, so let's draw what's going on here. If this is our north-south line, we're told that we have two airports. So this would be the north airport and this would be the south airport. And we're told that they're 52 miles apart. Now, we're told that the south airport sees a plane at a bearing of north, so we'd think of starting north and rotating 34 degrees west. Okay, so we see a plane there. The north airport sees the same plane at a bearing of south 56 degrees west. So we're told this is 56 degrees. How far is the plane from the north airport? So we're looking for that value there. Now the first thing we can do is find out what this angle is. And if on our calculator we do 180 minus 56 minus 34, we see that that's actually a right angle. So this is actually a right triangle. So drawn a little more appropriately, this would be 56 degrees. This would be 34 degrees, and this is x, and we know that this is 52. So 52 is actually our hypotenuse. Now, what we can do is we can pick either the 56 degrees or the 34. Let's go ahead and use 34 degrees, okay? Now, the x is the opposite side compared to the 34, and then we know the 52 is the hypotenuse. So we want to think with SOHCAHTOA, which one uses opposite and hypotenuse? Well, that would be sine. So we're going to set up the equation. Sine of 34 degrees equals x over 52. And now solving for x isn't so hard. We're going to multiply both sides by 52. So 52 times sine of 34 equals x. So we can do that on our calculator. Make sure your calculator is in degrees. So 52 sine of 34 degrees. So we see that x was about 29.1 miles. Okay, let's look at another one. So it says from a hot air balloon 1 kilometer high, the angles of depression of two small towns due west of the balloon are 81 degrees and 13 degrees. How far apart are the two towns? Okay, so let's go ahead and draw the situation. So we've got a balloon. Right, not great at drawing hot air balloons. We know that it's 1 kilometer high. Okay, and we've got two towns. So think of the balloon looking straight ahead. So the first angle of depression, 81 degrees. Or this would be 81 degrees. So this would be town 1. And then the other one is only 13 degrees. So this whole thing is 81. This one is 13. And we're looking for how far apart they are. We're looking for this distance. Now we might actually have to solve a little bit more to do this. First we should mention that the way we're measuring this is a right angle. Okay, so we've got two triangles here. We could think about the triangle down from the balloon into town 1. Okay, so let's label this Y. We know this is 1 kilometer. Now, we're actually looking at this triangle right here. And if the angle of depression was 81 degrees, and this whole thing makes a right angle, that this angle right here has to be 9 degrees. Okay, so we can use the 9 degrees and set up an equation to find y. So we can say this would be opposite and adjacent, so tangent of 9 degrees equals y over 1 kilometer. So we could multiply both sides by 1. We'd say y is equal to tangent of 9 degrees. So we see that that's 0.16 kilometers. Now we need to look at kind of the big triangle. I'll highlight it. So this big triangle, well, this down here would be x plus y. This is still 1 kilometer. And this angle of, it was an angle of depression of 13 degrees. So this angle in the triangle would be 90 minus 13. Which is 77. So this is 77 degrees. So we can set up another tangent equation, that tangent of 77 equals x plus y over 1 kilometer. So x plus y is going to be tangent of 77, which is 4.3 kilometers, or 4.33. So we know this whole thing is 4.33 kilometers. Now we were trying to find the distance between them. So this x is going to be 4.33 minus the 0.16. So we see the distance between the towns is 4.17 kilometers. So let's just, the distance between the two towns is 4.17 kilometers. Okay, so these were just two examples of how we can use the trigonometry to solve problems. We're going to look at another application of the trig functions here, and it's simple harmonic motion. So an object that moves on a coordinate axis is in simple harmonic motion if its distance from the origin d at any time is given by a cosine of omega t, or d equals a sine of omega t. So we're saying, you know, if you want to kind of picture something, so we have a coordinate axis, just a straight line, and you've got the origin, the 0 point. Then what we're doing is we're looking at how far an object is, so from that point, so we'd say D. And some things, they'll go out and they'll come back, and then they'll go out, they'll come back, out, come back, and that's called simple harmonic motion. One thing you can think, a spring. If you put a weight on a spring, so if this is a spring, and you put a weight on it, then how it would fall and bounce back up and fall and bounce back up, that would be simple harmonic motion. Okay, so the amplitude of the motion is the absolute value of this A value. The period, how long it takes to go through 1, is 2 pi over omega, and the frequency is 1 divided by the period. So this says an object in simple harmonic motion has a frequency of 1/2 oscillation per minute. Okay, so our frequency is 1/2 oscillation per minute. And an amplitude of 6 feet. So our A is equal to 6. Write an equation in the form D equals A sine of omega t for the object's simple harmonic motion. So we know it's going to be D equals 6 sine, and we need our omega. Now omega is given by, we know that the period is 2 pi over omega. Okay, and we also know that the frequency is 1 over the period. Another way to say is that frequency is the reciprocal of the period. So our period here must be 2, since the frequency is 1/2. So 2 equals 2 pi over omega. So if we solve for omega, we're going to multiply both sides by omega. So 2 omega equals 2 pi. Divide both sides by 2, so omega equals pi. So we can put that in here. And that tells us that this object, the formula that would describe it, would be D equals 6 sine of pi t.